Today we'll be looking at manometer. What is a manometer? A manometer is one of the most accurate devices for measuring pressure in the lower ranges. Since manometers are so accurate, they are often used as calibration standards. Some typical industrial manometer applications include fluid flow measurements, HVAC systems maintenance, residential or commercial furnace gas valve pressure measurements, and the list goes on. All manometers operate on the principle that changes in pressure will cause a liquid to rise or fall in a tube. Let's have a look at the types of manometers. A manometer is filled with a liquid. Typical manometer liquids are mercury, water, and light oils. It's worth saying here that mercury was a common manometer fluid in the past that has largely been replaced due to its environmental and health hazards. Quite often, the liquid is colored and to help detect the fluid movement. The tube is filled until both sides are approximately half full. When the pressures are equal, the column of liquid on each side will be at the same height. This is usually marked as 0 on a scale. With both sides of the manometer open to the atmosphere, the fluid level on one side will be the same as the level on the other side because P1 equals P2. Now, suppose one end of the U-tube manometer is connected to an unknown pressure, P1, whose value must be determined. The other end is left exposed to the atmospheric pressure, P2. The difference in the height of the liquid on the two sides of the tube is the differential pressure. In this case, the manometer provides a gauge pressure measurement because it is referenced to the atmosphere. So the total difference in liquid height is 4 units. And this is where the pressure measurement becomes interesting. Let's assume our U-tube manometer is filled with water. That means that our pressure differential is 4 inches of water column. As you can appreciate, a U-tube manometer filled with water is only capable of measuring very small pressures. If we replace the water with the Meriam red oil fluid, we'll get a greater difference in liquid levels. Water has a specific gravity or relative density of 1, while Meriam fluid is an oil and has a specific gravity of 0.83. We will get a much greater difference. We will get a much larger difference in liquid level with Meriam fluid, resulting in more accurate pressure measurements. In some cases, vendors will provide a U-tube manometer scaled directly in pressure units, such as kilopascals. Now let's look at another type of manometer, which is the barometer. A barometer consists of a glass tube with one end sealed. An evacuated tube has its open end submerged in an open container of mercury. The pressure exerted by the column of mercury is balanced by the pressure of the atmosphere. The glass tube is calibrated in pressure units. Any liquid could be used in a barometer, but mercury is used because of its high specific gravity. The mercury barometer needs to be at least 30 inches tall. A water-filled barometer would have to be more than 33 feet high. Let's look at the inclined manometer. A manometer that provides even better accuracy than the U-tube manometer is the inclined manometer. This manometer has a well that contains the liquid and a transparent column. The column is mounted at an angle. The pressure is indicated by the vertical amount the liquid rises or falls in the column. Because of the incline, a small change in pressure will cause greater movement of the liquid in the column. So these are different types of manometer. And today, we've actually seen how the manometer works. Having seen that, please share and subscribe to this channel to see more of these kinds of videos. And having seen the letter M, now A to Z Instrumentation Challenge, we'll be moving over to the letter N. So guess what letter we'll be discussing in the comment section. If I see you in the next video.